Okay, if I could have your attention, we're about to get started here in the Kestrel booth. We've got Todd, Hodnett, Bryan, Litz, and Nick Vitalbo of Applied Ballistics here. And at the end, we'll be raffling off a new Kestrel Elite weather meter with Applied Ballistics and link. So stick around.
Hi everybody, I'm Bryan Litz from Applied Ballistics. Like he said, we're going to talk to you today about the new Kestrel, and the Kestrel in general, and how it works with the Applied Ballistics software. Okay, so the three of us, we work together really closely on developing this product with Kestrel. My role in it is the ballistics, okay? So I wrote the ballistics solver and continually work to make it more accurate. Most of my time is spent in the ballistics lab doing live fire testing of a lot of different bullets. All right, so I measure the ballistic coefficients and we measure the custom drag curves for individual bullets, okay? So that, you know, BCs are good, they're an approximation of your bullet's flight performance. The G7 is a better representation than G1. If you're shooting through supersonic flight, the G7 is an adequate model of your bullet, okay? You won't be off target because of your drag model if you're within supersonic using G7. If you're shooting to extended range where you're shooting beyond the bullet's supersonic flight range, you can see some separation in your flight path from what's predicted if you're using BCs, and that's where the custom drag models come in. Custom drag models are live fired, measured points of performance for your bullet at transonic speed, and the only way to know that is to measure it with live fire. Okay, the predictions of transonic drag are very poor, and that's why we spend the time at the Applied Ballistics Lab measuring those things. All right, so that's my part of it. I also work on, implementing a lot of the feedback that we get from Todd as far as how to do the truing in the solver. Truing is an important part that we'll talk about. And Nick will talk about a lot of the connectivity and also the interface development. But I'll let these guys talk about their own parts. Todd will talk about the training and use of the Kestrel.
Yeah, my part basically has been, over the past decade or a little bit over, we've been training all the military units for all over the world. The ballistic engine is absolutely the best tool in the world for what we do with long gun training as far as our long gun shooting. And, going back to the days when we shot dope and we'd gather information and we'd go out and we'd try to repeat it with a different density altitude, the Kestrel has actually gave us a very simplistic tool to be able to do this without spending all the time changing density altitudes, gathering new range cards, doing all that. So now we can actually go in, zero our weapon system wherever we're at in the world, step out and true it at transonic or close to transonic speeds. So we end up taking 2-3 shots here, confirming elevation holes. And then if you need to, you can go out further into subsonic, do the same thing. That's when we true our DSF, that's the subsonic portion of it. And at that point, we can change. We can go anywhere in the world. I don't have to shoot a box of ammo with a 308 to be good with elevations hold out to a mile and get it anywhere in the world and be good anywhere in the world. So we gave it basically an easy button, and the user face as far as how we want the ballistic engine to work. Obviously, we're not rocket scientists like Bryan Litz is, so what we want is a simple tool that we can plug in. It tells us, hey, try this. We try it. Well, we may have to make an adjustment. We just plug in where the bullet hit. Since the bullet doesn't get to vote and doesn't get to lie, it has to tell the truth. Once we plug that in, we set the rules behind the scenes, the three of us, and then from that point, it takes care of it for you. You don't have to understand the reasons why. It takes care of it all the way through, and we haven't found a problem in probably since we've been working together. I hadn't found a gun that didn't follow in line with this set rules that we put into the engine to make sure that it's easy for you and it's perfect. A lot of times the guys say, well, what if you had a perfect G1 or a perfect G7 number? The deal is you need to understand that G1 model or that G7 model is still not the bullet. You may find the perfect number that is the proper comparison in that drag model, but it's not a custom drag model. It's not made for your bullet. It's still a G7 model or a G1 model. It's not a model made for your bullet, and that's what Bryan does. He figures out the custom drag models for your bullet, therefore you can true it transonic and not expect any deviation from the predictive algorithm to the actual algorithm that you're going to see once you start pushing out into subsonic regions. You want to go over some of the apps?
Yeah, sounds great.
My name's Nick Vitalbo. I end up doing a lot of the application development for the team here. The 5700 is the new Kestrel that we have out this year from Applied Ballistics. And There are two models. There's a sportsman model and there's an elite model. Both come with Kestrel Link. The Kestrel Link application is really neat. We no longer view the Kestrel just as a standalone product, but we think of it as the central product in a much larger ecosystem of products. And to do that, this year we launched two new things. We have a Bushnell laser rangefinder with the Connex connectivity in it. It allows you to take the range information from the laser rangefinder here. It automatically connects into the Kestrel. It then sends that range to the Kestrel. Your ballistic solution is computed, and then it actually sends it back to the laser rangefinder. So you can look through the laser rangefinder. You can still see what your holds are inside of it without having to have the Kestrel in your hand. Of course, that information is redundantly displayed on the Kestrel itself, but you can see it right through the laser rangefinder also. In order to make things easier to manage for setting up the Kestrel, we've developed a couple of applications this year as well. One of them being for Android and one of them for iOS. They're called the Kestrel Link Ballistics applications, and you can find them on the Google Play and the and the iPhone stores as well. Those two applications allow you to set up all your guns if you like, get access to all of the custom drag curves that Bryan has measured, and upload them onto the Kestrel. And that is a nice user interface to just very quickly upload the information there and push that to the Kestrel. There's a couple of other things you can do with the applications as well. You can see the weather vane that we have set up here. One of the particularly useful things is to be able to set the Kestrel in that weather vane and take live weather and wind readings from it. You can set up the device so that it captures the wind continually and then beams that to your phone so that you can see exactly what the wind holds should be while the Kestrel is measuring the wind speeds, which is really awesome. Another one of the things we added was multi-target engagements, basically. This came out of a lot of the recent PRX type of matches that everybody's shooting this year. So what you can do is you can enter in, let's say, up to 8 targets, the range to target. So when you're getting to a stage, for instance, you would then enter in the range to each one of the targets. Then you compute it on your Kestrel, and then it comes back and displays in the app. And then I wear it like on my wrist when I'm shooting. That way I don't have to actually pull the Kestrel out of my pocket or anything. I just look directly on the phone at those holds. So as you can see, we have a lot of new stuff going on, and you can see that we're continually developing new applications and new products to connect into the Kestrel. So we're really excited about it this year because this is really, I think, one of the key enablers to really connecting everything together with the Kestrel being the central product there. So I think at this time we're going to ask questions.
Yep. Does anybody have any questions about the new Kestrel, ballistics in general? All right, so the question is, how are the custom drag curves measured? And there's a couple ways that we do that. It's a lot of live fire. There's very little prediction that goes into this. We base everything on careful live fire measurements. So one of the ways that we do it is we fire the bullets through transonic and measure the time of flight through transonic. And we've discovered a lot of interesting things about that related to twist rate. Another way that we can do it is shooting over shorter distances, measuring the start and end velocity, basically measuring velocity decay over a shorter range. And in that case, so the principle is easy, right? You're measuring velocity decay, but the devil's in the details. So you would download the cartridge to replicate lower velocity flight at long distance. But what you have to be careful of is that you're matching the spin decay, all right? As the bullet flies, it loses its forward velocity much more rapidly than it loses its spin rate. So your bullet might leave the barrel at a 1 in 12, one turn and 12 inches of flight, but by the time it's gone 1,000, 1,200 yards, it's lost a lot more of its forward movement than it has its rotational. So at 1,000 yards, that bullet that started at 1 in 12 might be spinning a 1 in 8 or a 1 in 7. And so if you want to replicate that long-range, low-velocity flight condition, you got to match the spin condition of the bullet there too. So the short answer is we measure discrete points at different speeds to generate a curve, which is the drag profile of that particular bullet. That's the short answer. But to do that right without getting errors in your data, there's a lot of careful attention to detail that we have in the lab when we're doing this live fire data.
Any other questions?
I want to mention sticking around. Yep.
Yeah, so I'll elaborate a little bit on truing, and then we'll stick around for questions. Truing is one of the most common questions about the Kestrel. What is truing? How does it work? So ideally, okay, in the perfect world, whenever you give the Applied Ballistics solver accurate inputs, including muzzle velocity and drag model and all those things, you're going to get an accurate solution. Now, there's a whole list of reasons why your shots wouldn't be on target, right? Now, the Kestrel takes care of atmospherics. The sensors on the Kestrel, they're seriously accurate sensors, right? They're NIST traceable all the way back to international standards, so you know you're getting the atmospherics literally live wired into the ballistic solution. The drag modeling is done through live fire at the lab, so that part is solid, but it's very common to have errors in muzzle velocity, right? Or have errors in how your scope actually tracks.
Or have errors in companies that tell you what the BC is of the bullet that they're selling that may not be real.
Right, so there's one way or another, uncertainty creeps into the system, and your long range drops may not be what the Kestrel predicts if there's uncertainty in the inputs that you give it. And that's where truing comes in, okay? So if you have an opportunity to shoot at a long range target, you're gonna look for a target near the transonic range of flight where your bullet slows to about 1,340 feet per second. That's maximizing the portion of the bullet flight that is predictable in the supersonic range. You're gonna observe your drop on that target, and you're gonna tell the computer how much drop you actually had there. Let's say it calls for 8.7 mils, you hit with 8.9 mils. If you tell it that, it reverse engineers your true muzzle velocity for that to happen, and now you're locked in for that distance and much further beyond there. Now, the thing that you have to understand about truing, whenever you're truing your ballistic solver, you're actually doing a calibration exercise. Okay, so you have to be a whole lot more careful than you would be if you're just shooting at a target. Okay, if you have a target at 800 yards, you can deal with 10 meters of range uncertainty. You can deal with 5 degrees of temperature uncertainty. You might not have to worry about aerodynamic jump or Coriolis or those kind of things, but whenever you're truing your muzzle velocity, any error that you make is going to follow you everywhere you go. Just like when you do it right, you're good everywhere in the world. Well, if you do it wrong or you overlook some of these details, you'll be wrong everywhere in the world. So when you're truing the ballistic solver, that's when you have to take extra care on measuring range and getting your atmospherics updated in the Kestrel. So if nobody has any more questions, we'll be sticking around after this to answer questions one-on-one, or you could ask them now. Yep.
Are you guys working on anything to get a better wind variation reading along the ranges? Obviously here it's going to take fire as wind.
Yeah, I think the question was, are we working on any instruments to give us different wind readings for the ranges? Obviously, Invista has some products that we can actually set out on the range, but I think you're talking more about real-world situations. There's products coming down the line that will actually read wind for you. Hopefully, you'll see some of this. It's been something we've been testing in the military since 2008-9. So initially, well, we're not going to get into a lot of that right here, but it's working. Its form factor, its size, its cost. We know that stuff is coming down the line later. Maybe something that actual shooters can use, like us, on the range, hopefully in the next 5 years.
As far as the wind measurement that you get with the Kestrel, though, to put that into perspective, the Kestrel is a great tool for baselining your wind, right? If you're in an environment where the wind is consistent between you and the target, and you measure it where you're at, well, it's going to apply all the way from you to the target. So in that case, the measurement from the Kestrel is basically telling you everything you need to know about the wind. If you're in an environment where the wind is different between you and the target, you can only measure it where you're at with the Kestrel. So in that case, you would have to, it's the wind, man. It's a dynamic fluid that changes all the time. So in that case, for this time, you've got to kind of use your judgment and experience to account for those variable wind fields downrange.
Yeah, reading mirage, again, going back to reading mirage, reading veg, looking at terrain features, look how it's going to manipulate wind flow patterns. Again, that's the experience side of it. That's the nemesis of long-range shooting, is making those wind calls. And I used to hear people say all the time, yeah, wind at your position means nothing. It's the only known you have. Do not ignore it. If you did only one thing, I'd tell you get a good wind reading at your location and shoot that. Experience in will say, hey, there's potentially you're in a portion of terrain that gives you dirty air. You're going to have to understand that. Wind flow coming off the hill, kind of creating a dirty wind flow pattern. Looking at vegetation downrange, Doesn't really work where I live. It works in other places in the world. Wind blows every day, a lot where I live. So usually anything that's going to move very much gets whipped to death and dies within the first year. So most of the time, though, you can look at the mirage pattern, look at the mirage pattern on the horizon, wherever you're in focus. That's the range that you're looking at, that wind or that mirage pattern, and you're reading the wind. So if you're focused on a target at 500 and move up to a potential horizon 3 miles away, if you were focused at 500 and moved up, you're actually reading the mirage at 500, but at that level above the target. All right, so it's not like you're reading mirage, 3 miles off at that point, unless you focus at that point. So, there's a lot of different techniques, but again, that's the nemesis of long-range shooting. The number one thing I'm going to look at is my Kestrel reading. Absolutely 100% of the time. I'm always going to read my Kestrel reading, take that into consideration when I'm making that wind call.
Yeah, you can use the Kestrel to sort of train or calibrate your own wind reading, right? So, years ago when I was trying, I'm still struggling to learn to read wind. It's a constant struggle, but to put a number on it, like you see the leaves blowing or you see certain indicators. Well, how much is that worth? I started taking the Kestrel with me, walking the dog. Looking around. Okay, I think this is about a 5 mile an hour wind. Okay, it's 7. And you do that, it doesn't really take long before you can really close the loop on what you're observing versus what it actually is when you have a measurement to actually, to know what it really is. You have an instrument to really measure it. So it's a valuable training tool to kind of calibrate your own judgment as well as having it on the range when you're actually shooting.
Yeah, we do that every day with the guys out on the range. Most of the time the military guys, they live on bases, with the exception of maybe Fort Carson where we actually have good wind. All right, so most of the places that we go in the military, there's not a lot of wind. But when they get out to me, they're not used to shooting in that type of wind. So I tell them, hey, calibrate yourself. Get out of the truck, feel the wind, kind of lean into it and go, I can hear this much wind, I can feel this much wind. Take your Kestrel out, look at it and go, okay, that's 23 miles an hour right now. And you do that through the day. By the end of the week, you jump out of the truck and go, okay, that's about 17, 18 miles an hour. You pull it up, you may be missing it by 1. It's just calibrating yourself, but you need to do it with a good instrument. And then proper cosines, which that's one of the new things with the new Kestrel. We have 30-minute clock directions that you can actually plug in. So it's much more accurate and give you wind turned into mils with a proper cosine as opposed to just going 1 or 2 o'clock, which is a huge deviation in cosines. Now we got 1, 132. So it's much better and much more accurate.